All right, and today we are going to focus on naming covalent compounds and writing formulas for covalent compounds. So we just spent the last couple days looking at ionic compounds only, so today we're going to focus on covalent compounds, if I can get it to go forward. The difference here is covalent bonds or covalent compounds, atoms share electrons. Ionic, there was a transfer. Electrons physically went from one atom to the other. With covalent, they are sharing. And this is also between a nonmetal and a nonmetal. Ionic was a metal and a nonmetal. So here we're talking about both nonmetals. We're only going to be focusing on binary covalence, so it's just simple compounds that only have two elements. Naming. You're going to find that naming these compounds are going to be quite simple compared to what we've been doing for the last couple days. The first thing you need to realize, again, that they are both nonmetals. On the test, I'm not going to tell you if it's ionic or covalent. You have to know that. So this is what you're looking for. You're looking for that the two elements involved are nonmetals. To name the compounds, you simply write the name of the element and you use a prefix to indicate how many there are. Now, there are some exceptions to this process. For example, if it's the first element, we don't use the prefix mono. And the second element, we always change the ending to IDE. It's as simple as that. Name the first element with a prefix, name the second element with an IDE ending, also with the prefix. To write the formulas, it's just backwards. So we know what the elements are because it will give us the names, and we just write the symbols, and the prefix tell us how many there are. Let's look at, first the prefixes. The orange chemistry help sheet, for those of you that are in the building, you should have gotten these last week. If you are online only, you will need to print one of these off unless you were one of the online kids that came in during that first week to get it. But you will be given these prefixes. You don't have to memorize them. So if I look at this, I want to name this compound. So it's P2O5. So the question is, what's P? Look on the periodic table. P is phosphorus. There's two of them. What is the prefix for 2? Which would be di. Next is O5. O is oxygen. Because it's the second element, I change it to oxide. And there's 5 of them. So what's the prefix for 5? Penta. And put it together, that's the name of the compound. Diphosphorus pentaoxide. Simple, right? So let's look at some examples. Go ahead and pause the video here and try to do these 4 on your own. Let's look at some answers. CO2, there is 1 carbon and there are 2 oxygens. And since we don't use the prefix mono on the first element, it's just carbon dioxide. N2O4 becomes dinitrogen tetraoxide. P4O10 becomes tetraphosphorus decaoxide. And then the last one, CO, carbon monoxide. Notice here we do use the prefix mono. We just don't use mono on the first element. There's only 1 carbon, there's only 1 oxygen, and so oxygen gets the prefix mono. Simple, right? Now let's go the backwards direction. A couple of reminders. This is important. This is one of the more common mistakes that students make, is because we spend so much time dealing with ionic compounds and naming ionic compounds and writing formulas for ionic compounds. You're so accustomed to looking at that pink sheet to find the charges that when we get to covalent compounds, you continue to do that. But remember, There are no charges. These aren't ions. Ions are the result of a transfer of electrons. That electron goes from one atom to the other. We are not transferring electrons, we are sharing electrons. So there are no charges, there is no crisscross method. The pink sheet is, for all intents and purposes, irrelevant when we are dealing with covalent compounds. The only thing you need to name a covalent compound are the periodic table and that orange sheet that has the prefixes. If it's covalent, put that pink sheet away. Let's look at an example. So here we have dinitrogen tetroxide. So I know what the element is. It's nitrogen. And the prefix di tells me how many I have, which would be 2. Tetraoxide, the oxide tells me it's oxygen. The prefix of tetra means 4. And so what's my formula? N2O4. It's as simple as that. 3 more problems. Go ahead and pause the video and try to do these on your own. Let's look at the answers. Carbon monoxide should seem familiar. CO. Nitrogen dioxide. Since there is no prefix on the nitrogen, that's how I know there's only one of them. And then the dioxide, I know that there's 2 oxygens. Diphosphorus pentoxide is P2O5. And that's it. And hopefully that was fun and refreshing, that something in chemistry class seems so easy. But let me warn you, you have to determine whether it's ionic or covalent. One of the pitfalls that students fall into is they use this covalent process for everything. So these prefixes are only for covalent. It's only covalents that are simple. And that kind of gives you a hint on what do you think there's going to be more of on the test? These easy covalents or more challenging ionics?